Welcome back to Math 103. This is video number 3 on measuring power. Last time we were looking at all the different coalitions in our example of the 3-member advisory committee to the New Jersey governor. A coalition, we were saying, is just a group of players all voting yes together. Now, only some of those actually have enough votes to pass a motion. Only the ones that have at least 5 votes, because we just declared from the beginning the quota was exactly 5, only those coalitions with exactly 5 votes or more are winning coalitions. So if we look more closely just at this collection of the winning coalitions, we can ask, is there a simple way to describe the list? In other words, just in words, what does it take to pass a resolution? And then what can we infer about the share of power which each player, that is, each committee member, actually has? Okay, well, as for a verbal description of what it takes to pass a resolution, well, either you could have everyone voting yes, or you can have 2 committee members voting yes, and here's the real point. Any 2 committee members will do. It doesn't matter which 2. Any 2 committee members, or all of them, have enough yes votes to pass a resolution. Now that's actually very important for our analysis. Any 2 committee members who vote yes can get a resolution passed, and since it does not matter which 2 vote yes together, that means that the 3 players in this weighted voting system have equal influence in forming winning coalitions. They are interchangeable in a certain sense. They play equivalent roles. Or, to put it another way, they have equal amounts of power, equal amounts of actual power on this committee. That leads us to a very important, albeit surprising, conclusion. Allocating votes in a 4-to-3-to-2 ratio does not appear to distribute actual influence, actual power in a 4-to-3-to-2 ratio. That would have meant that each player had a different amount of power. What actually happened was that they all had the same amount of power, right? So since the 3 committee members play equivalent roles to one another in the dynamics of forming winning coalitions, it turns out that our intuitions were wrong. And actually, that's a good reason why we have mathematics working for us. We need to use mathematics to sort out what's actually the case and point out when our intuitions are incorrect. So this is really a key point, and if it's not clear, I urge you to make it clear before you continue. This is an absolutely crucial point for what's going on in this subject. Allocating votes in a certain ratio does not have the desired effect of distributing actual power in that ratio. It just doesn't work out that way when you analyze the dynamics of forming these winning coalitions. So we still have a lingering question here. What would it even mean, concretely, for the actual power of the committee members to be in this 4-to-3-to-2 ratio? We can recognize when they play equivalent roles, as they do in this example, but what would it mean to measure the power in this precise kind of a way? We will study 2 mathematical techniques for answering this question. One of those techniques is the Banzhaf Power Index, which has been very useful in real-life court cases dealing with determining whether certain distributions of power are fair. We'll come back and discuss what that really means. For now, to understand this approach to measuring power, measuring how much actual power each player has in a weighted voting system, here's a useful narrative. There is a committee, not necessarily our 3-member committee from before, but just some committee that's debating whether to approve a certain proposal or to reject it. Before the official vote is taken, so the narrative goes, the chair asks the committee members privately how they intend to vote. Based on what they tell the chair, there do appear to be enough yes votes for the proposal to be approved. So then what happens on the day of the actual vote? Well, then there's some question about whether one particular committee member, whom we'll call Sam, who initially said yes, there's some question, will Sam now switch sides and vote no? Now, in this narrative, all the other committee members are firmly dedicated to their original yes positions or their original no positions. The only doubt is about Sam. And Sam is thinking about switching sides. The key question in this scenario is, what effect does it have on the outcome, if any, for Sam to switch from voting yes to voting no? In particular, if Sam switches from voting yes to voting no, are there still enough yes votes for the proposal to pass? In this case, it doesn't matter what Sam does. It doesn't matter that Sam switches sides. Or, are there no longer enough yes votes for the proposal to pass after Sam switches? In this case, it makes all the difference that Sam switches sides. Now, if the proposal will pass anyway, then in a certain sense, Sam has no critical role to play in making the proposal pass. And therefore, and this is the key idea for Banzhaf, Sam does not exercise real influence in this scenario. Okay, if there are enough yes votes out there already, that Sam's contribution to the yes total is not going to make a difference whether Sam does join the other yeses or not, then Sam does not exercise real power in that scenario. But if the proposal will suddenly not pass, all because Sam has switched sides and cast no votes instead of yes votes, then in a certain sense, the entire outcome depends on Sam. And therefore, Sam exercises actual power in this scenario. Right? Sam is determining the outcome of this election. Before going on to the next video, answer the following two questions. So we're going to return to our example of the New Jersey Advisory Committee set up as the weighted voting system with quota 5 and weights 4, 3, and 2. So suppose that Northern and Central Jersey, with weights 4 and 3 respectively, suppose that Northern and Central are all in favor, or both in favor, and S, the Southern New Jersey, is opposed. If Central Jersey switches sides from voting yes to voting no, does the proposal still pass? And the second question is, suppose instead that all three are in favor of a certain proposal. Now, if C switches sides from voting yes to voting no, does the proposal still pass?